Power law for logarithms. I'm going to show you how to use it, and then I'm going to show you why it works. First off, the power law for logarithms is this. If you have the log, let's say base b of x to the n, that is equal to n times the log base b of x. That's the power law. What that's saying is if you take the log of a power, that exponent can be brought down in front of it. So I'll show you with a couple of examples. Let's say I've got the log base 10. So if I don't write a number in there, that's base 10 of 10 to the 3. According to this law, that's equal to 3 times the base 10 log of 10. Now let's see if that works. 10 to the 3 is 1,000. So the log, base 10 log of 10 to the 3 is the base 10 log of 1,000, which is 3, because 10 must be raised to the exponent 3 to give you 1,000. I'm assuming you know what a log is by the time you're watching this video. 3 times the log of 10 is 3 times the log of 10. The log of 10 is 1. So that's 3. So this checks out. Now I'm going to prove it in letters so that you know it works afterwards, but just showing you a few examples of it here. So a couple of questions from your homework. One of them is you're to evaluate, find the base 2 log of 16 cubed. Now if you take 16 cubed, it no longer is a power of 2, so it becomes a little bit tricky. However, if we use this rule, you can bring the 3 down. So you've got 3 times the base 2 log of 16. The base 2 log of 16 is 2, 4, 8, 16. It's 4. The base 2 log of 16 is 4. So I've got 3 times 4. So this is simply equal to 12. Now I think I misspoke. I said when you cube it, you no longer have a power of 2. Actually, yeah, you do have a power of 2. It's just this huge number that's harder to deal with. Okay, I'll do a slightly more complicated example here. Let's say I want to find the base 4 log of the 5th root of 16 to the exponent 15. Okay, looks like a big complicated mess. Now, first thing I'm going to do is apply some exponent rules. You better be right on top of your exponent rules before you even start working with these log rules. This is the base 4 log of the 5th root of 16 is really 16 to the 1/5. And now when I'm finding the power of a power, so if I take a power and raise it to yet another exponent, I multiply the exponents together. Again, review your exponent laws if that's not perfectly clear. So this should be 16 to the 15 over 5. Okay, so what did I do here? The 5th root of 16 is 16 to the 1/5. And then when I take 16 to the 1/5 and raise it to the exponent 15, I multiply the exponents together. Now I've got the base 4 log of 16 to an exponent. I can use the power law and say that is 15 over 5 times the log base 4 of 16. Again, the power law is whatever the exponent is, you can just bring it down and multiply the log by that exponent. So the exponent turns into a factor. 15 divided by 5 is 3, so this is 3. And the base 4 log of 16, 4 times 4 is 16, so the base 4 log of 16 is 2. So the whole thing is equal to 6. That's using the power law. Okay, now why does it work? So I showed you how you use it. The the main use of it is actually to solve exponential equations, but that'll be a whole other video. So this is really just getting to know, getting to use the power law right now. Why does it work? Imagine you have the base b log of x to the n. Now, if I can demonstrate that this is equal to n times the base b log of x, I've demonstrated the power law. To try and figure out what this is, let me call it y. So I'm going to manipulate this, so I don't know what it is yet, so I've just given it another letter. And once I've done that, I can rearrange this equation into exponential form. Now, you don't need to know all this to be able to use it. If you can just memorize it, you can use it. I'm just showing you why it works. Appealing to our definition of a log, what this is telling me is that when I raise b to the exponent y, that is equal to x to the n. That is the very definition of a log. Remember, a log is defined implicitly, not explicitly, and the log of a power gives you the exponent. Okay, knowing this to be true, I can then take some further steps here, and my goal right now is to get x by itself. The reason why I want to do that, you'll see when I convert it back into log form. If I'm raising x to the exponent n, I can raise both sides of this to the exponent 1 over n. So on the right, I have x to the n over n. Again, that's an exponent law where you get to multiply a power of a power. You get to multiply the exponents. And over here, I've got b to the y over n. Well, n over n, no matter what n is, as long as it's not 0, is 1. N over n is 1. So x to the n over n is simply x. So b to the y over n is equal to x. If I were to write this exponential equation in log form, and you must master going between exponential equations and log form, going back and forth. You can look at the other video if that's not perfectly clear. There's one that just says it's Introduction to Logarithms. Anyhow, this is now the base b log of x is equal to y over n. Again, I just used the definition of a log. So that's the exponential form, and that's the log form of the same idea. Now let's do a little bit of work to it. Multiply both sides by n. You end up with n log b of x is equal to y. However, remember, y was equal to, we started out by saying y is just a stand-in for the base b log of x to the n. If y is the base b log of x to the n, and y is n times the log of the base, n times the base b log of x, then, since y must be equal to y, the base b log of x to the n must be equal to n log base b. That's the proof of the power law. That's why it works. Okay, so this is the power law for logs. Why it works is demonstrated here. We convert the log equation to its exponential form to manipulate it and then convert it back. And in identifying that this y is the same as that y, the base b log of x to the n must therefore be equal to n times the base b log of x. So this, because this rule worked with letters, this works with whatever number you use. So again, I'll show you how to use that. Just grab another question out of your book. The base 2 log of the square root of 8. To evaluate this, the square root of 8 is 8 to the 1/2. So this is the base 2 log of 8 to the 1/2. Now using the power law, I get to bring that exponent down. The base 2 log of 8 is 3 because 2 times 2 times 2 is 8. That's 3 of them. So that is 1/2 log base 2 log of 8. So I'm just going to finish this example real quick before I answer the phone. That is 1/2 of 3, which is 3 over 2.